Control. You can actually resolve that little issue by pressing stuff on top. You don't need to walk all the way over there.
Okay, I guess this is
Fine. Success.
success. Mike, say hello to the rest of the
Well,
offline people.
Me and
Alex.
Alice.
Let me just see.
Alex.
Yes, we get that. Well,
Are we presenting on
Where's the
first
beer?
part mail encryption?
after.
Oh,
We
okay.
don't miss. Come on, you know that.
You guys did some cryptography, I'm sure. Cryptography. A little.
Photography, is that
know
close?
this.
We were sending we were sending the Roman cipher messages in.
So I plan
PCP, PCP.
to rush today for a good piece of cryptography, but rush. So if someone doesn't know it, then I will just talk about it. So we have some piece of cryptography of wise uses and some ciphers, some very rough explanation algorithms. Then we will go for the practice, which will be part of actual email encryption. And a bunch of keys. And email clients, yes, it's fine. And this is just a bunch of stuff that will try to be mnemonic about how it's used. So yeah, why would you use cryptography? Most of the time, the military used cryptography, like in the beginning of the 20th century, to figure out how to pass messages in a kind of secret way. At that time, how you encrypted the message, how you processed it, how you changed the letters through, was the way how they made it secret. No one knew how to process the message back, so yeah, it was secret. So now this doesn't work really well, because implementing an algorithm is quick. You can communicate the algorithm to the enemy quickly. So you have instantaneous communication. It doesn't work really. The way how we do it today is that we have an algorithm that everyone knows how it works. We have the key, which is the information that's secret, and that's kept secret. And both together work to put a message in a way that it looks secret. Yeah,
I'll
I think that's
explain it. Do you know the locks that if you close them, they doors that if you close they get locked? So imagine you have a box. You could put something inside and you can close it, and only someone else has the key.
no, that's
Yeah?
not yet that.
That's
That's just generic cryptography. Like why we have the key.
so
Because you could have a symmetric one yet.
you can have a symmetric, meaning we could both have a key and we'll just send boxes.
Boxes between
Yes.
people. Yeah.
But the trick would be we lock the information inside the box and send it, and we assume nobody can break it.
So the interesting part of today and the interesting part of email for this is that email is incredibly easy to read. It's incredibly easy to read. I can pick that machine, log into Hermes. I ask, what's your email address that you normally use?
From Gmail.
Email.
It's Jose Luis dot g at gmail.com.
Good. Audit normally use also Gmail, yeah.
Gmail.
It's loaded.
Yeah, .17.
17, blah, blah. So I can log in there to Hermes and send an email from your address to his address.
Sorry,
I can log into Hermes, to
Mhm.
our, or to RIA or to any other server from that machine, and send an email from your address to audit address.
Yes, but I will receive the email based on this is spam or something like this, or there are duplicate. I am working in an application that does this thing, that is sending emails using my account, and I am receiving the same emails, creating an account, receiving all the time that the message that I receive in Gmail is the maybe it's not a right address or something like this. But you receive some problem.
But the RIA is nice because a lot of stuff comes out from RIA anyway.
Mm-hmm.
So Gmail is not marking that IP here as back as something that the emails don't go away.
Mm-hmm.
Yes, or MailChimp or something industrial that sends mail.
If you have something that sends mail and sends enough mail, you can send email as any person.
Yeah, wonderful. And also you can send 1,000 mails to your enemy.
So that's not the best form of communication if you want to maintain one, privacy, and if you really want to know who you are communicating with. That's definitely not the best way of communication, but people are very confident that it is.
Mm-hmm.
Right?
No, they listen to everything.
Hmm?
You remember your last 10 minutes of your life, you put a chip in you.
Yeah. So,
Organic, so.
lack of privacy, like the idea of putting a message in neat secret, we all normally call confidentiality. And we have talked about the idea of key, and that there's basically algorithms that can encrypt it. So I still can send an email to you, or I even can send from your address to Odet's address, but in a way that only selected people that they will give the key on a piece of paper will be able to read it. That's a way of encrypting things. And, well, cryptography is full of strange terms. Let's see if you guys know clear text, plain text. Yeah, ciphertext, I'm sure you found that. Context. Well, that's what we're talking here. Normally you have two people that want to talk to each other. If there's no two people that want to talk or send some information from one to the other person, there's no point of any encryption.
Yeah. Mm-hmm. That's the best way to have security. Don't speak with anyone.
Yes.
Lock yourself in a room.
Security in a nutshell. Don't communicate.
Don't communicate. That works even for disk encryption.
So,
You store the data on the disk, take the disk and burn it.
It's very secure.
It's very secure.
That's all works good for discovering secret keys.
Ah, yeah.
Cipher. Often people call that the algorithm. So I am using ICE cipher, or DES cipher, or RSA cipher. RSA is not a really cipher. Encryption scheme. Because if you say I am using an ICE cipher, ICE is a standard, it's not telling really much. You still can say, oh yes, I am publishing this is my key for ICE on my internet page, and I'm sending everything under ICE, and that's not confidential at all. So the scheme is what you do with the key, how you deal, what piece you keep secret, or what piece you show, where you encrypt. There's an entire set of algorithms that you need to follow, otherwise encrypting anything is still not secure at all. It's just trivial. That guy is making that mistake. I just explore that, and I will see it in clear anyway. I don't need to decrypt anything.
Second World War all over again.
Yeah. Security is a dodgy word. It's just talk it. Burn the data, it's secure. Destroy the data, it's secure. But what we really care today is that a secure way of communicating, that we will try to achieve that, and adhering to some guarantees. So we'll describe some stuff that we know we can do that. And when we take a bunch of those, we assume that is secure communication. it might